Today I'm in Destin, Florida, and today we're going to be doing an inspection project on a 300-foot condominium, and we're going to be using the DJI Mavic 3 Enterprise to capture imagery in order to create a photogrammetric 3D model. Now, the inspection that they have to do is going to be assessing the quality of the building, making sure that the structure is intact, and finding any flaws or problems that might exist. And it's important to get a good inspection done on your building because it's the right thing to do. Special thanks to BECI and Skand for sponsoring today's video and giving us an opportunity to take a look at an inspection project. Now, I had the chance to talk to Josh Tatum, a professional engineer and an expert in the field of inspection, and find out a little bit more of Florida's legislation. Hey, Josh.
Hey,
see you.
Yeah, good, sure. So at BECI, we're a consulting company that specializes in the building enclosure. So anything you see on the outside of the building is what we touch daily. The biggest problem that I think condominium owners are facing is, number one, understanding what the legislation is. How do they respond to it? What is the actual context? We as condominium owners respond to it, but then also on the legislator side of the pushback they're getting from the industry, from the professionals that have to fulfill what they've asked them to do, and from the condominium owners that just don't know how in the world they're going to get it done. With this legislation, there's the ability now so that people have to be responsible in the maintenance of their building. What we as an industry don't want to allow to happen is that the tragedy of Surfside, the immediacy and the impact of that caused legislation to change, that they don't allow it to happen again through, neglect. What it does better than anything is it just brings attention to the fact that these are really important parts of the building that must be maintained, and then unfortunately they do cost money to maintain.
Right. I'm joined by Gordon Porter, a drone pilot from BCI. Show us a little bit of the setup that you've got and what we're going to be doing for the inspection of Grand Dunes 2.
Yeah, of course. So I actually fly a Mavic 3 Enterprise DJI product. It's amazing the quality that you get out of it.
One thing that we've done to position ourselves more favorably to be able to accomplish those is partner with a company called Skand. And what Skand is able to do is build essentially a digital double of the building. They take a drone or some other data collection device with a camera on it, and we take and build a model of the building based off that data collection.
It's typical 8K camera, and it can zoom up to 52 times. Best we can tell, it still remains about 1080p even at 52 times, so it's an incredible camera.
And so with this extreme level of resolution and really high megapixel camera, you're going to be able to get a lot more detail without being so close to the building.
That's right.
And that's a big safety point that a lot of people have when they're doing inspections, is that they don't want to be colliding into any kind of objects.
Yeah, absolutely. And also to the photogrammetry side of things, you want several photos of the same location, but at multiple layers.
Right. Different angles to be able to reconstruct it.
That's right.
Yeah.
Yep. And so the more layers you have, the more clear your final product will be when it comes to 3D modeling, which is what we're doing with this.
Now, with that information and that model, I can inspect that building from anywhere in the world because now I have it right on my computer. Additionally, there are artificial intelligence components of this that are recognizing things like cracks, spalls in concrete, things that would lead an engineer to say, well, I need to go take a little bit closer look at this.
So Gordon is going to show me what goes into creating the mission plan in order to execute an inspection project on a building of this size. This is a 300-foot building. So let's take a look and see what he has to do in order to get the drone to know where it needs to be in order to capture all of the data that it needs for the project.
So the best way that we found to actually start the flight planning software, particularly with Drone Harmony, this is the software we use, is Drone Harmony. I'll go to Google Earth and I'll build an HTML file in Google Earth. So I'll go to the address and I'll just type in Grand Dunes 2. All right, so this is the Google image of Grand Dunes 2. So what I'll do is I'll start adding points at the foundation of the building, and this part's critical because the roof, given skew, given the building, and that's I'll add points to follow the roof line. And being a KTML file, all these points that are put into Google Earth, and it builds the polygon in Google Earth. All of these points are GPS coordinated. Now the nuances in the building, there's some debate over whether getting each little nook and cranny like this is important. I say it is, just so that you're 100% accurate. Some like to just build a generalized rectangle, or at least a multi-sided polygon around the building, but not following every curve of the building. And call this grand 2.
So now you're exporting the KML file that we just created on Google Earth.
That's right. And then I'll come over to Drone Harmony, and you'll import areas. This is specifically for the polygon itself. So I'll import that. All right, clear previous site data. I'll take that off, continue, and you'll see it puts polygon right where it needs to be.
Oh, that's sweet.
And you can see it's off center from the building itself, the roof building. It's actually showing you the actual foundation location of the building, and it accounts for skew here. So what we were looking at on Google Earth, the roof is going to move around based off where you put your focal point on the screen. This polygon is set to the GPS location coordinates of the actual foundation of the building, the exterior corners. We have our missions, which is our different rings. We build those in the office, and you can actually click here. This is another building I've put in just to make sure that we're not hitting it. And that's all these little squares that you're seeing along here are your waypoints, and it'll take a picture at every point.
So while the drone will be flying up here in the real world, we'll be able to monitor it on the controller, and having that virtual model is what's allowing us to plan this correctly. And that way you don't have to guess when you're out here and hope that you don't hit anything.
That's exactly right. Now it does take a lot of front-end work and getting the flight plan exactly right. For that reason, whenever you're building it on a flight planning software, everything's relative, right? So you're dealing with Google Earth, there's skew, there's all sorts of different factors you have to consider. Once you get on site, you can adjust that accordingly, and then once you get it where it needs to be, it's a breeze. It flies itself and it maintains its own distance.
That's awesome. I love that.
Where we can step in and help, hopefully, our clients is to make sense of it, to make sense of what needs to happen in between now and when the law's in effect. But there are a couple of shot clocks on there that say you have to have this done by this date. And we have a little bit of grace period right now to really navigate that. So now's the time to start.
Gordon is sending the mission plan over to the drone now. Once the drone has all the information and it's been uploaded, it'll give us the ability to start flying. And then it will fly around the entire condominium, giving us all of the imagery we need for our photogrammetric image processing.
The geospatial world has been alive and well in the surveying world for a while now. We're just now at the tip of the iceberg on how that can be applied to buildings.
There it goes.
You can see in this view, it'll give you an idea of where it's at in the flight, and this view actually is the first person view of the drone.
Very cool.
Okay, so it's around the back side of the building now. Of all days to fly a drone, this is not the ideal day just for shadows and things. As far as 3D modeling is concerned, honestly, the best models come from full shade, meaning there's no shadows, there's no texture issues, things like that. It's very clear all the way around.
Usually the same as with mapping as well. Whenever we fly aerial and nadir mode, it's always better to be a cloudy day.
Yeah.
So now you're going to set up the mission to go around the building at different altitudes.
That's right.
And that way you can get more details on every level of the building.
Yeah, that's right. Yeah, so it'll fly concentric rings around the building at a given distance off of the building. We preset that in the software, and we'll have multiple missions for multiple distances. What I'm about to fly now is just a perimeter. This is a facade mission, so this is specifically for the 3D model. In addition to that, we'll also have closer missions that are more along the lines of 10 meters away, 30 feet or so, that'll be specifically for inspection. So in the 3D model, you can actually turn the model around to where you want it. If there's a specific area that you want to look at, you can click directly on the model and it'll bring up an inspection photo that's GPS synchronized with the model, so you're actually looking at the particular part of the building in detail that you want to look at.
Now we can put this into a monitoring program, meaning I could create that digital twin today and basically freeze that at a moment in time. I can then go ahead and create that digital twin a year from now and see how things are progressing and see how through monitoring, do we actually have an issue? Or is this something that maybe is no longer an issue, or will become an issue, and say, I can see the trajectory of it, and now I can look at it 3 years, 5 years out, and see, are we progressing in a positive manner or negative manner, and when do we actually need to address this?
Today's we completed 5% of that mission, so I'm going to select that and go back, press launch. It's talking to the drone, and off it goes.
When we had a lot of, these really strong hurricanes hitting the state, all of a sudden the way that the state responded was that they were going to tighten up on building codes, make buildings more resilient to these strong winds. But if we look back at what those building codes did, is they put sound principles in place that if you look at these strong hurricanes that are hitting today, they created resilient structures. I think that the legislation is going to follow the same path. I think there's probably an overreaching piece of the legislation now, but it's not going to go away, and it's going to continue to do good. What I would suggest to a homeowner is that you plow forward, that in fact you go ahead and get the inspections that are dictated by the law. One, I don't think they're going away. Legislation has proved that they're here to stay, and so I would recommend you plow forward because it is the right thing to do.
Now that we've finished flying the entire building, let's take a look at this 3D model and see how well it turned out. All right, let's take a closer look at the data that was processed for the Grand Dunes condominium. We're going to be viewing this data on an online cloud service known as Skand. They're a resource that provides you online data management and gives you flexibility with representing your data for your client. So right here, I can see the condominium after it's been processed. Right here is the front where Gordon and I started. You can zoom in here and see just how much detail there is from all of the imagery that was captured by the drone. You can even define where the balconies are for each individual unit. So that is some really beautiful data that was captured by the Mavic 3 Enterprise. Now, all of this data is geo-referenced, and we can assign whatever coordinate system we want. So down here at the bottom, I have NAD 83, Florida North, and in Florida, we use the US survey foot. So I've chosen US Imperial. I hit confirm, and now my coordinates are up to date for NAD 83 Florida North. You can also turn on a base map to see where you're located, and you may notice that this cuts off the building, and that's because part of this building is beneath mean sea level. The reason being is that, well, the ocean is right here, so it actually makes sense that some of the elevations are below zero. Nonetheless, it's nice to see that the project is coming in geodetically correct. So traditionally, you could take a bunch of images with your drone and try to sift through all the images, but you'll have a very difficult time trying to understand where you are spatially located in the project. That's why in Skand, they have an image viewer option, which allows you to select an area, and in that area, a collection of images that belong to that specific point will appear for you to use for inspection. So if I open up the image viewer and let's say I want to, inspect this side right here. Suddenly all of these images show up, and I can pick any one of these images. And now I can zoom in and see what is happening in the facade of this building. Now this is really nice because I can actually pinpoint the exact location that I want to look at something. And of course, since I have 100% coverage, I'm able to see all of my defects. Traditional building inspection utilized cameras that are on the ground, or having to send somebody up on a balcony or a rooftop in order to take images of the building. You usually get between 20 or 30% coverage, and there is a safety factor that needs to be put into place because you're putting someone's life at risk when they're at high altitudes. But with a drone, I can literally see every aspect of the building, and I don't need to worry about missing anything because there's full coverage thanks to the hundreds, if not thousands, of images that were taken. So as humans, we are only capable of seeing certain defects. Yes, it's definitely a lot easier to go through the model like this, but we're still going to miss a majority of the defects that are in this building because we just don't have the ability to go through every single image and identify every single problem. Skand is using a model that has been trained since 2016, and with 7 years of training, Skand is able to identify these defects automatically and represent them in the model. So if I turn on the defects layer, you can see a bunch of polygons show up, and these are all defects filtered in different priorities. So if I open up the defects here, I can select filters, and we can see different types of filters. So you can go based off of the status, the rating system, the different types of defects, all sorts of different ways of filtering through these defects. I'm going to go to the risk filtering and I'm going to turn on priority 3. So we are going to look at all of the priority 3 defects. These are defects that we should monitor and make sure they don't grow into something more critical. However, they are considered imperfections in the inspection. So something like this up here at the top of the building, we can see that there's some kind of leaking happening in the roof causing this damage up top. And this looks like a larger than normal defect. While it might not be as critical, it is growing. So if you are doing an inspection every year, for instance, you can go back to your previous year and see how the size of this defect was. And if you see that year after year it's growing, then maybe you may want to put some attention towards it. If it's the same size, then perhaps it's a cosmetic defect that is not impacting the structure of the building. So you could leave it alone. You could prioritize other defects, but it's nice to be able to see the change of this defect over time. And here you can see ponding, so it's water being collected at the roof. Very nice that we can see that. Another defect that the system noticed was right here. When we select on the roof, we can see that there is some damage here on the roof. And if you look just below it, you can see that there are footmarks. And there's actually a separate defect identified here. So I'll select that. And it says surface defect. And yeah, sure enough, somebody was up on this roof and their footprints are on the facade of the building. Something that probably no person would have ever saw, but a computer vision model was definitely able to detect this and present it to the user. Definitely a really cool and useful tool to have whenever you're doing a building inspection. Now let me show you what some priority 2 defects look like. All right, so if we look at the roof here, I can see in the HVAC system there's a defect right here. So the computer vision model is telling us that this is something that needs to be taken care of in the near future so that it doesn't turn into a bigger problem. Another priority 2 defect looks like something is broken in either a window or a door. And sure enough, it looks like the door closing mechanism that you find at the top of doors. Probably whoever's living here hasn't really said anything to maintenance, so it's been left broken. So now using this inspection, we're able to identify this. So now we can send somebody out to fix it. One major problem that this condominium has, and you can see all the purple around here, is the gutters. All of these gutters right here seem to have some what they call pawning. They're all filled and they're not functioning properly, which means they need to hire somebody to go clean out all the gutters. Now, priority 1 defects are generally high risk issues. This can include objects hanging off the building, structural issues with the building that can cause it to collapse, or anything that needs immediate attention and could seriously harm the safety of the people that are either living or working there. Thankfully for Grand Dunes, they have no priority 1 defects, so it seems like this building for the most part is a-okay. Couple of defects that need to be taken care of in the next few months for priority 2, but nothing that needs immediate attention and could risk the safety of its residents. Now, these priorities are set by the engineer that is working on the project. So if I hire somebody like BCI Consultants to come and do a building inspection for me, their engineers are the ones that are going to set the priority based off of the risk tolerance in my area. So since BCI is very familiar with the Florida market, they know which types of defects have which priority. And so they can go into Skand and they can set their priorities based on their knowledge. Lots of flexibility, lots of use cases for this type of technology, and it's all based off of your input as the engineer. Now with this model, I'm able to use the annotation tool to mark up anything directly on the model if I have some kind of objects of interest. Let's say I see these antennas up here and me being, a curious customer, I want to annotate these antennas. I'll get a precise measurement of the annotation. So you can see everything here is in the US survey foot because that's the units that we set up. Now I have my polygon that was drawn. I get some metadata about the area of interest that I put in, and I can say, antenna details, and then pick a category. So this to me is an object of interest. So now when I talk to the engineer and say, hey, I want more information about these antennas, which antennas am I talking about? I can direct them to the objects of interest and the annotation that I placed in the drawing. If I want to add an image, I can take a screenshot of my view of the model. So there we go. I want this image to be added. And there we go. And I can add an overview image, something that's maybe pulled back a little, but I think this is enough. And I could say, hey, what is this antenna for? ? Save. All right, now my annotation has been saved to my objects of interest. Now this is a live model that is cloud-based, so anybody can access it from any computer, but not anybody can access this model online. Perhaps you need to take it offline and you need to create a more formal PDF report. You can do that automatically without having to spend endless hours putting it all together. All I have to do is come to the Reports tab in Skand. I will create a report. I'll call my report Grand Dunes Defect Report. And then I can select what objects I want to include. So I'm going to add my defects that are in priority 1, 2, and 3. I will select all of my defects. I will say add to report. So all the defects are in the report. And then maybe I want to add in my object of interest that I put in, my antenna details. We'll add that to the report. And here's all the information that I have added. It all looks good to me. I'm going to create the report. Now the report is being created, and this does not take very long. This takes maximum 1 or 2 minutes. All right, and the report is completed, so I can view the report, and there we go. We have location for where the defect is, and then images and different priority rankings. We have the ID for the defect, the priority, and what type of defect it is and what it's impacting. So every little thing is in here. This is really, really nice, really handy. And if I needed to export this as a PDF, I can go back and just click download. There we go. And would you look at that, we have a full report in PDF, so it can be taken offline. This report is 400 pages long, so definitely very time consuming had I had to do this by hand. But with Skand, I'm able to generate the report automatically, seamlessly, very easy, very good. And now I can show this off in a more conventional way with just a PDF without missing any of the defects. But if I can use the online model and somebody wants to go online and view it in 3D, I can come over to the Share Links button. I can give it a name, so I could say Grand Dunes Model. And then under the link content, I'm gonna select this pencil. And then I can include whatever I want. So I'm gonna include all of the defects and maybe my objects of interest. I'll click Save, and then I'll create the link. And now I have an active link right here. And based off this link now, I can then identify which features I want to be available. I'll hit copy, and then I can send that link off to whomever I want, and they can view the model without having to download any software, without having to have a robust computer, and it's all cloud-based running off of Skand's server. And that's it. That is how you do a building inspection on a building that is 300 feet tall. If you're looking for a service like this yourself, be sure to check out BECI's website down in the description. You can click the link for the model down in the description as well. And from sunny Florida, I will see you guys next time.